The last topic from this chapter, that is scattering theory of particles, that is relation between the cross sections. Okay, so we have this relation between the cross sections in center of mass and the lateral frame. So in the previous lectures, in yesterday's lectures, we have seen the condition that is related to your cross sections. So we have the solid angle. Let us say in terms of the center of mass system, this solid angle is given as d omega dash is equal to 2 pi into that sine of theta dash into d theta dash. Okay, that is, now we have to consider the number of particles that is scattered in solid angle d omega dash, or you can say in terms of a center of mass frame, and that must be equal to the number of particles which are scattered in the laboratory frame. So we can have two terms, d omega dash in terms of center of mass frame, d omega in terms of laboratory frame, and that must be equal to 2 pi sine of theta into d theta. Okay, so we have already seen the symbols. Okay, theta is for laboratory frame, whereas in terms of theta dash, that is in center of mass frame. As the number of particles which are scattered through this center of mass and laboratory frame are same, we can write this the number of particles, that is 2 pi r into this sigma theta dash into sine of theta dash into d theta dash, and that must be equal to 2 pi r into sigma theta, okay, into this sine of theta into d theta. So yesterday we have seen this part, okay, 2 pi r sigma theta dash sine theta dash into d theta dash. That is nothing but the number of particles which are scattered in center of mass and in laboratory frame. What is sigma theta? Sigma theta is nothing but d sigma by d omega. That is nothing but the differential cross section, okay, in terms of laboratory frame, and this sigma theta dash, this is nothing but d sigma by d omega dash in center of mass frame. So we will see this, we'll just come to know that these two terms, these three terms that will get cancelled out, and we'll have a condition, that is this sigma theta dash that must be equal to this sigma theta, okay, multiplied by this sine of theta divided by the sine of theta dash multiplied by d theta by d theta dash. We can have these conditions. Sigma theta dash is equal to these things. Or I can write this as this sigma theta dash is equal to this sigma theta. Now I can just rearrange these terms in terms of a derivative. So I can write derivative of this sine theta. We just want this term, and we are divided by derivative of this cos of theta dash. What is derivative of cos theta? Derivative of cos theta is sin theta into d theta. Derivative of cos of theta dash is nothing but sin theta dash into cos theta dash. So we have to use this relation. So we number it as the equation number 1. So we'll have the simplest thing as the number of particles scattered in solid angle d omega dash in center of mass frame, and that must be equal to the number of particles which are scattered in laboratory frame, okay, or in terms of a solid angle d omega. Now we have to use one relation. We have an identity or a trigonometric relation, that is cos square theta is equal to 1 upon 1 plus tan square theta. So what we have to do? We have to use these terms, that is, we have to find out the values of this derivative of cos theta upon derivative of cos of theta dash. Okay, so we can just use it. So from this I will write the value of cos theta is nothing but 1 divided by square root of 1 plus tan square theta. You will remember the point, that is, we'll have an equation between the angles. ठीक है, जैसे अपन elastic scattering पढ़ा तो बा, in that elastic scattering we have a relation, and that relation is nothing but this tan of theta is equal to this sin of theta dash divided by this m1 upon m2 plus cos of theta dash. So this is the relation between theta and theta dash, scattering angles. Here upon relations पढ़ा दो बा in terms of the position vectors, velocity, momenta, and we can have that angle. So we have these relations. So I'll just use the value of that tan theta here. So I'll just write it like this. So I'll have a term, that is this cos theta is equal to, look at this one, 1 divided by square root of, what is the term? 1 plus the value of this, that is nothing but this sin square theta, theta dash, okay, divided by the square of this term. So square of that term is nothing but, I can just say, this is cos square theta dash plus twice m1 upon m2 into this cos theta dash plus, you can have a term, that is m1 upon m2 bracket square. सगळ्यांनी लक्ष देगा पहा, इथे काय tan square theta याची व्हॅल्यू आपल्याला इथे टाकायची. सो tan square theta is याचा स्क्वेअर, that is sin square theta dash divided by the square of this term. So a square plus b square, a plus b square, that is a square plus twice ab plus b square. Now we just take an LCM and I can just write these equations as, so I'll have this, that is the value of cos theta. So this cos of theta is equal to, look at these things, 1 divided by, we'll just take an LCM, and that LCM is, this is m1 upon m2 bracket square, and just write the first term plus twice m1 upon m2 into cos of theta dash plus the third term, that is cos square theta dash plus the term that is left here, that is nothing but sin square theta dash, and that must be divided by the value of this, that is this value, that is m1 upon m2 plus this cos of theta dash into the square. What is this value? LCM. LCM का है cos square theta plus twice m1 plus m2 cos theta dash. What is this? This is nothing but the square of this term. So I can directly write it this. Okay, I just take it on the numerator side and I can write that there is the value of cos theta is equal to this cos of theta dash plus this m1 upon m2, and that is divided by, what is that? We can have a term that is cos square theta dash plus sin square theta dash is equal to 1, and so you can have a value that comes out to be 1 plus this twice m1 upon m2 into cos of theta dash plus the second thing, that is m1 upon m2 bracket square. So we'll have this value of cos of theta dash. What do we want? We want the derivative of cos theta divided by derivative of cos of theta dash. So in order to find it out, what we have to do? We'll have to just take a derivative of this term. So I'll just rearrange this. I can take this term to the numerator side and I can write this as, that is 1 plus 2 m1 upon m2, okay, into cos of theta dash plus this m1 upon m2 bracket square and raised to minus 1 half. You just take it out. We'll have these terms in the form of u into v. So we'll just say the derivative of cos theta, okay, so what is that? That is nothing but the derivative of the first term. So I'll just write derivative of this cos of theta dash plus m1 upon m2, okay, second term as it is, so there is nothing 1 plus twice m1 upon m2 into this cos of theta dash plus this m1 upon m2 raised to 2 and it's raised to minus 1 half. So this is the first thing. What about the second thing? The second thing is plus the first term as it is, that is cos of theta dash plus m1 upon m2, and the derivative of the second term and the derivative of this term is nothing but minus 1 half into the term 1 plus 2 m1 upon m2 into this cos of theta dash plus this m1 upon m2 bracket square. Now look at this. What is the power? Minus 1 half minus 1. So this will become minus 3 by 2 into the derivative of this term. सगळ्यांचे लक्ष द्या, आपल्याला याचा डेरिव्हेटिव्ह काढायचा आहे. तो पहिल्या टर्मचा याचा डेरिव्हेटिव्ह minus 1 half times raised to minus 3 by 2. Now the derivative of this, once the derivative is 0, m1 upon m2 is mass which is constant. So that's a derivative is 0. So you can say the term is twice m1 upon m2 into the derivative of the last thing, that is derivative of cos of theta dash. Okay, so I just cancel these terms, minus 1 half and plus 1 half, and now I'll have the equations, and that equation that should be written like this. I'll just remove some part of this. So I'll get a term that is derivative of cos of theta. Okay, that must be equal to, what is this? The derivative of the first term is nothing but derivative of cos of theta dash. Okay, the derivative of the second term is 0, so you can have only one term left, that is derivative of cos of theta dash multiplied by this thing, that is 1 plus twice m1 upon m2 cos theta dash plus m1 upon m2 bracket square raised to minus 1 half. Now we can have these terms left. So you can have these conditions. Look at the conditions that I just write this, and then in the next term I'll have that equations. So this term is as it is, which is having a power raised to minus 1 half. Okay, then you can have a minus term. Then this term is as it is, bracket is as it is, which is having a power raised to minus 3 by 2. That is not the right way to write these conditions. I'll just write all the things. So this is 1 plus twice m1 upon m2. This is cos of theta dash plus m1 upon m2. This is bracket square raised to minus 1 half. Okay, minus this thing, that is 1 plus twice m1 upon m2. So I'll just take it to the denominator. Okay, and so you can have a term left, that is nothing but this is m1 upon m2. Okay, into this derivative of cos of theta dash, and that should be multiplied by this value, that is cos of theta dash plus this m1 upon m2, and which is divided by the term that is nothing but 1 plus twice m1 upon m2 into this cos of theta dash plus this m1 upon m2 raised to 3 by 2 plus it's square and raised to 3 by 2. So we can have this condition. सगळ्यांनी लक्ष देताय का बा, एकदम थोडीशी रिअरेंजमेंट केलेली आहे. So derivative of cos of theta dash is nothing but derivative of cos of theta dash. Theta is equal to theta dash into that term plus. Now we can have a minus sign, so we minus sign लीजिए. m1 upon m2 into derivative of cos of theta dash. ये एक term है ठीक है, and दूसरी term निकली है, that should be multiplied to this term cos of theta dash plus m1 upon m2, and that should be divided by minus 3 by 2, that will becomes plus 3 by 2. Now what we'll have to do? We'll have to just take an LCM. ठीक है, याचा जर LCM आहे, LCM will raised to 3 by 2 bracket multiplied by raised to 3 by 2, and so we'll have to multiply it here, and so I can write it like this. You just take it out. Relations कशी येतात ते पहा. So what do we want? We want this relation So we can have a conditions, that is the derivative of cos of theta. Okay, इथेही derivative of cos theta dash है, इथेही derivative of cos theta dash है, याच्यातलं तर बाहेर काढूया, and that will be transferred to your LHS, which will get divided by, so derivative of cos theta upon derivative of cos theta dash, ही term आपल्याला पाहिजे, ती term आपल्याला इथे मिळते, so which is equal to, just check it out, this is 1 plus twice m1 upon m2, okay, into this cos of theta dash plus this m1 upon m2 bracket square raised to minus 1 half and LCM है bracket raised to 3 by 2. So this is nothing but 1 plus twice m1 upon m2 into this cos of theta dash plus this m1 upon m2 bracket square raised to 3 by 2 and minus this term. So this is totally divided by. So I'll just write this. I'll write it here. So I can have this term. So I'll write it on the downward side. That is m1 upon m2 multiplied by this cos of theta dash. Okay. Plus, now this will becomes minus into plus. This will becomes minus m1 upon m2 bracket square, and this is totally divided by this 1 plus twice m1 upon m2 into this cos of theta dash plus this m1 upon m2 bracket square raised to 3 by 2. So you can have this condition. Now what will be your final term? The final thing is that, just check it out, the power is minus 1 half and we have this 3 by 2. So I write this as derivative of cos of theta divided by this derivative of cos of theta dash, okay, and that must be equal to, what is that equal to? Look at this, minus 1 half plus 3 by 2, how much? That is 2 by 2 is equal to 1, and so we can have that term, that is 1 plus 2 m1 upon m2 into this cos of theta dash plus this m1 upon m2 bracket square, okay, minus what? Minus is m1 upon m2 into cos of theta dash and minus this m1 upon m2 bracket square. That should be divided by the term, that is 1 plus twice m1 upon m2 into cos of theta dash plus this m1 upon m2 bracket square raised to 3 by 2. So what will be your final thing? The final thing is that the derivative of cos theta, okay, divided by this derivative of cos of theta dash, and that must be equal to, look at this one, the first term is 1, now this is plus m1 upon m2 cos theta dash minus m1 upon m2 cos theta dash, we can have a term that is 2, so this term will become m1 upon m2 into cos of theta dash, and look at this term plus and minus, and that is divided by the term that is 1 plus twice m1 upon m2 into cos theta dash plus this m1 upon m2 bracket square raised to 3 by 2. So we can have this is number 2. काय केले का आपण काय म्हटलं की जे काही नंबर ऑफ पार्टिकल which are scattered in center of mass frame and lateral frame are equal, when they are equal we will obtain this relation in terms of your scattering cross section sigma theta dash is equal to sigma theta is equal to derivative of cos theta upon derivative of cos theta dash. Now we have to find out the value of derivative of cos theta upon derivative of cos theta dash, and for that we will just use this condition. Okay, cos square theta is nothing but 1 upon 1 plus tan square theta. So we want cos theta, and that is nothing but square root of 1 plus tan square theta. What is tan theta? So we have already obtained the relation for the tan theta, that is nothing but sin theta dash upon m1 upon m2 plus cos of theta dash. We just put that value and we can have this condition. So cos of theta dash that can be obtained in this way. So we have taken the derivative. इथपर्यंत आलं, इथे येऊन आपण डेरिव्हेटिव्ह घेतलं आणि डेरिव्हेटिव्ह फक्त आपण सॉल्व केलं and so we obtain the relation, that is derivative of cos theta upon derivative of cos theta dash is nothing but 1 plus m1 upon m2 into cos of theta dash divided by 1 plus twice m1 upon m2 cos theta dash plus m1 upon m2 bracket square raised to 3 by 2. Now we'll have to put this equation number 2 in equation number 1 and we'll obtain the relation for sigma theta dash, and the final relation for this is given like, you can have that final thing. So this is sigma theta dash. What is sigma theta dash? That is the differential cross section in center of mass frame, which is equal to the differential cross section in your laboratory frame, and that must be equal to, or that is equal to into this 1 plus this m1 upon m2 cos of theta dash divided by the bracket 1 plus twice m1 upon m2 into this cos theta dash plus this m1 upon m2 bracket square raised to 3 by 2. So we can have this in the third equation, and that is nothing but the relation between your cross sections. Now we'll have two different cases. The relations are the relations of the. Now we'll have the different cases for this. So for that we require some conditions. Okay. So the conditions are like this. We'll have this points, that is cos of theta is equal to cos of theta dash plus m1 upon m2, okay, divided by square root of 1 plus twice m1 upon m2 cos of theta dash plus m1 upon m2 bracket square raised to 3 by 2. So now we will obtain the two different cases, and from that we will just see what should be the relations. जसं आपण हे रिलेशन्स वापरून वेगवेगळ्या केसेस पाहिले होत्या, when m1 is very greater than m2, m2 is very greater than m1, or when m1 is equal to m2. So we'll obtain the three different cases. So we'll have to look at the conditions, and the conditions are like this. So we can have that relation that cos of theta is equal to cos of theta dash plus m1 upon m2. So I can write that in our normal way, that is 1 plus twice m1 upon m2 into this cos of theta dash plus this m1 upon m2 bracket square, okay, raised to 1/2. We can say it is in terms of square root. So I just have that look, that is, this is the term which is the square root. Okay, आहे तशीच दिलेली आहे, काहीच फरक नाही आहे. So I just remove this part, and so you can have that term, that is your cos of theta. Now what are the cases? The cases are very simple. The first case is that if m1 is equal to m2, if this m1 that must be equal to m2. So we are looking at the scattering of the particle. So the case is that the incident particle and the target particle is same. So m1 is equal to m2, that means the particles are called as identical particles or identical particle scattering. And so for that purpose, we can have the first thing, that is this cos of theta, okay, that is equal to, this is cos of theta dash plus 1, okay, and it is divided by, as m1 is equal to m2, and it is divided by 1 plus this 2 into cos of theta dash plus 1. So what is this value? This comes out to be 1 plus cos of theta dash, okay, and it is divided by square root of 1 plus 1 2 plus 2 cos of theta dash. Now what is numerator? Numerator is 1 plus cos of theta dash, denominator is square root of 2 plus 2 cos of theta dash. So I can just take square root of 2 outside and I can write this is 1 plus cos of theta dash, and which is divided by root 2, that is taken out. Okay, so into square root we can have a term that is 1 plus cos of theta dash. सगळ्यांना लक्षात येते का पहा, cos of theta is equal to cos of theta dash plus 1. So we can have this term that is 1 plus cos of theta dash divided by square root of 1 plus cos of theta dash. So what is the value for this? We can write this, that is equal to cos of theta dash, which is equal to, ठीक है, this is one term that is divided by this, so it is having raised to power 1 and square root of 1 plus cos of theta dash. So I can write this is 1 plus cos of theta dash divided by 2, and all the terms are in square root. So this is square root of 1 plus cos of theta dash divided by square root of 2. So I can write it like this, square root of 1 plus cos of theta dash divided by 2. What is that value? This value comes out to be square root of cos square theta dash by 2. So this comes is cos of theta dash by 2. So what we can write? We can write that this theta dash is equal to, this theta is equal to this theta dash by 2, or we can write this theta dash is equal to twice theta. What does it mean? It means that the scattering angle in center of mass, then, that is twice as compared to the scattering angle in terms of the difference. So this theta dash is equal to twice theta. So I just use that value here and I can write the conditions. So what should be the conditions now? The conditions should be like this. So you can have this, that is sigma theta dash is equal to, this is sigma theta. What do we want? We want the relation between sigma theta dash and sigma theta. So we can have that sigma theta dash is equal to sigma theta multiplied by the term 1 plus this cos of theta dash, because m1 upon m2 is equal to 1, because m1 is equal to m2, and that is divided by the term 1 plus 2 cos of theta dash plus 1 and raised to 3 by 2. So what will obtain? We'll have the conditions, and just remove this equation number 3, just remember that, and so you can write that the sigma theta dash is equal to sigma theta, okay, and that should be multiplied by 1 plus this cos of theta dash divided by 1 plus 1, that is 2, plus 2 cos of theta dash raised to 3 by 2. Again the same situation. इथं जशी situation होती तशीच situation है. So what you can write? You can write this is equal to sigma theta dash is equal to sigma theta, and that is multiplied by, what is that? 1 plus cos of theta dash divided by, what is the common thing? That is 2 raised to 3 by 2 into 1 plus cos of theta dash. Okay, raised to 3 by 2. So look at this term. This is having power 1. This is having power raised to 3 by 2. So what is the term which will remain? So the term which remain is 1 plus cos of 2 theta. Second लक्ष्य देते हैं. So we just take it out like this. So 3 by 2 minus 1. So this is 2. 3 minus 2 is 1. So raised to 1 half. So you can have that term that can be written as, that is sigma theta dash, okay, is equal to the sigma theta multiplied by 1 plus cos of theta dash. लक्षात घ्या, 1 plus cos of theta dash divided by, we can have that term that is 1 plus cos of the conditions. Now the point is, you not have to look at the conditions on the same way. The problem is, we'll have to put the value. Okay, so I'll just write it here. That is, this theta dash is equal to 2 theta, so this becomes twice theta. this will also becomes twice theta. So you can also have the term this is twice theta into this twice theta. Again, this is twice theta, and this is also twice theta. So this theta data will get removed, and so you can have this term that comes out to be, that is sigma theta into this 2 raised to 3 by 2, and so this is 1 divided by, the term is 1 plus cos of 2 theta. So this is 1 plus cos of 2 theta, and so what is that value? The value that comes out to be cos of 2 theta raised to 1 half, and this comes out to be cos square 2 cos square theta, and so at right hand, that is sigma theta dash is equal to sigma theta into 1 divided by 2 raised to 3 by 2 into 2 cos square theta raised to 1 half. So what is that value? The value that comes out to be sigma theta dash is equal to sigma theta into 1 upon 2 raised to 3 by 2 multiplied by 2 raised to 1 half into cos square theta square root मतलब बाहर क्या, that is nothing but cos of theta. And what is that value? This value comes out to be this sigma theta dash is equal to sigma theta into 1 divided by 2 raised to 3 by 2 plus 1 half. So 3 by 2 plus 1 half, that is nothing but 4 by 4. So 4 by 2. So we can have that conditions. आणि परत एकदा त्याचे काय करायचे, व्हॅल्यूज कॅल्क्युलेट करायचे. So this comes out to be I think 4 cos of theta, and so we can have this value, that is sigma theta dash or sigma theta is equal to 4 cos of theta times sigma theta dash. So you can have that is the relations between your scattering cross sections in center of mass and laboratory frame. So laboratory frame, that can be 4 times cos of theta times your angle or cross sections in the center of mass frame. So this is one case. The another case is very simple. So the case is like this. So you can have the second case. This is the first one when m1 is equal to m2. Now the second case when m2 is very greater than m1. So when this m2 is very greater than m1, that is the mass of the target is very greater as compared to the mass of the projectile. And so what is the relation? You can have m1 upon m2, that comes out to be 0. So just put that value here, and you can have that. Just check it out the conditions, that is sigma theta dash is equal to sigma theta into cos of theta dash plus m1 upon m2 divided by 1 plus twice m1 upon m2 into cos theta dash plus this m1 upon m2 is greater raised to 3 by 2. That is our relation. Okay. So what is that? This value that comes out to be 1. So you can have that values when m1 upon m2, that should be when m2 is very greater than m1. So you can have that conditions, that is this value. Just put the values m1 upon m2. When this tends to be 0, so you'll have that all the terms, and you can just set this sigma theta dash. Okay, that comes out to be equal to sigma theta. So you can just say this scattering cross section in laboratory and center of mass frame, that must be equal. So these are the two different cases, and that's all for your scattering theory of particles. हे मला वाटतं परत एकदा तुम्ही